Hey guys, so just a few questions for you to think about. And the first question is, why isn't it a good idea to classify matter? And we know matter is anything that has mass and takes up space by its phases. Once again, why isn't it a good idea to classify matter by its phases? And if you think about it, there's a photo. You have three phases of water in this photo. You have solid, which is the iceberg, liquid, which is the water, and then gas because it's air, right? So if I wanted to classify this, it probably wouldn't be a good idea because they're all still water, right? And there you go. You can't classify matter by phases because one kind of substance can exist in more than one phase, such as H2O. Matter changes phases rather easily, so we can't classify matter by its phase. Okay, so what about color? Could we classify matter based on color? I have a pot of gold and then a sunflower in the actual sun. All of those are the same color, so we can't classify matter by color because we wouldn't find it useful. Like they're all gold, but the sun and solid gold aren't even the same phases. So this is what we are talking about today. We are on a new standard, and the essential question is, how are elements, compounds, and mixtures related? The new standard we are learning about is SAP 1B, which states, describe the difference between pure substances, elements and compounds, and mixtures. So today we are going to talk about elements and compounds, all right? So before we could classify matter, we actually had to figure out what matter was. And we know matter is anything that has mass and takes up space. All right. So big picture, we've learned all about matter. Now we're going to talk about how we classify it. All right. So in this photo right here, you can tell that we can classify matter as a substance or a mixture. Today, we're going to focus on a substance. All right. Once again, we can say matter is either a substance or a mixture. And today we're going to focus on substances. And a substance is all particles in matter are identical and they have a fixed composition. All right. So just the makeup of them. All particles of matter or the makeup of that matter is in a fixed composition. All right. So we're going to make it easier. We're going to skip mixture because we're going to go over that tomorrow. All right, so when scientists decided or figured out we need to actually classify matter, these are the questions that they ask themselves. Is the matter uniform throughout, meaning does it look all like exactly the same throughout? Can it be separated by physical means? And can it be separated by chemical means? And this is what they came up with. Okay? We got to have some characteristics. So we know that matter can either be a pure substance or a mixture, but what is a pure substance? So a pure substance, there's some characteristics. So a pure substance has a fixed composition, distinct properties. It cannot be separated into simpler substances by physical methods, meaning even if you cut it in half, it's still the same substance. It can only be changed in identity and properties by chemical methods, like a chemical reaction. And the properties do not vary one sample to another. And I know that's a lot, but we're going to break it down. Okay, we learned about pure substances, right? And we know matter can be separated into pure substances or mixtures. And then we have pure substances. And there are two pure substances, which are elements and compounds. There are two pure substances, which are elements and compounds, okay? Here is your photo, just so you can see. Matter, anything that has mass and takes up space. We're over here where it's pure substance. And now we're going to talk about elements, okay? An element is the simplest form of matter from which more complex substances are made. Everything on the periodic table, I know you have seen it, that is an element. So oxygen, hydrogen, nitrogen, lithium, potassium, carbon, those are all elements, all right? So they're a type of substance. All of the atoms that make up an element are alike. And they give you an example, helium. And I gave you way more. Everything that you see on the periodic table, those are all elements. All right, so an element is a molecular look, okay? And they can exist like helium, argon, neon. Those are stable as individual atoms, okay? They could also exist like hydrogen, nitrogen, oxygen. They're stable as two atoms, diatomic molecules of themselves that are bonded together. So if we were looking at just photos, the green, these are elements. They're by themselves, okay? They cannot be, if they were broken down or cut or split, they would have the same composition. And then you have these diatomic molecules or compounds, and it's two of them, but they're exactly the same. So it's like two hydrogens stuck together or two oxygens stuck together, all right? They're exactly the same. And then you have compounds, okay? So we have elements, and now we're going to talk about compounds. Compounds are two or more elements chemically combined in a fixed proportion. They can be broken down, but only in a chemical reaction. They have properties that are different than the elements that make them up. So compounds that you know of and you use in regular life, water, H2O, okay? H2O, so those are two elements that have come together to make a compound. Salt, NaCl. Na is an element, Cl is an element, but when you put them together and they are chemically bonded, they create a compound. And then you have sugar, all right? It is also a compound made up of different elements like carbon and hydrogen, but when you put them together, they create a compound. There we go. So NaCl. Na is an element, Cl is an element. When they come together and they bond, they create a compound. Sugar is C6H12O6. C, carbon is an element. H, hydrogen is an element. O, oxygen is an element. But when you put them together and they chemically bond, they become a compound. All right, so what is the difference between an element and a compound? The difference is an element is just one substance in the simplest form, meaning oxygen, and you can tell it's the same color. Or a compound is two or more elements that are chemically combined, like carbon dioxide. And if I'm looking at the photos, the elements are the same color because it's just one substance. Whereas a compound, you have two different colors, all right? Because there's two elements that have been chemically bonded to make a compound. And you guys, that is where we're going to stop, and we're going to practice because practice makes perfect.